I'll just give you one simple problem to think and solve. So the question is calculate x component of the force. So Fx is the x component of the force for a pair of Coulomb particles. So that's the question. So calculate the force between a pair of Coulomb particles. You can take 5 minutes to solve it and get back. Welcome back. So the question was calculate the x component of force between a pair of Coulomb particles. So what I mean by Coulomb particles? So basically I just indirectly said that the particles are charged, and when the particles are charged, you basically calculate their potential by using the Coulomb's law. So the particles which can be whose potential can be calculated using the Coulomb's law, I call them as Coulomb particles. So what would be the force between two such charged particles? So the hint is to calculate the force, you have to know the potential. So force is nothing but the gradient of potential. So if I know the potential between two particles, then you can get the force, and you know the potential between two charged particles. So the potential between two charged particles, we already have saw that we already have seen is Zi Zj divided by 4 pi epsilon 0 Rij. So if you have that potential, you basically take the gradient of negative gradient of that and you get the force. But here I want the x component of the force. So how do you go about it? So to get the force component of x, we have to make use of thermodynamic some thermodynamic rules. So one such rule is what we'll be employing here. So when I say the x component of force, so I am basically trying to get del u del x. So now since I want in x component, I take the potential, I take the gradient in x component only. So minus del u del x I can write as del u del r, and I can write this as del r del x. I'm sure you have seen this multiplicity relation in thermodynamics. So del u del x you can write as del u del r dot del r del x, and now let's find out what is del u del r and what is del r del x. So your u was Zi Zj divided by 4 pi epsilon 0 r. So my del u del r is equal to minus okay, I can give I here, yeah. So my del u del r I is minus Zi Z divided by 4 pi epsilon 0 Ri square. Yeah, Rij is the interparticle distance we are talking about. So is minus zi z 4 pi epsilon 0 I j square. So this is my del u del r. What would be my del r del x? We know r is equal to x square plus y square plus z square to the power half. So therefore, my del r del x would be minus half, it will be half 2x, and then we have x square plus y square plus z square to the power minus half. This is a simple derivative, and so that is nothing but x divided by r. So if you put them together, what we get is minus x by r zi z j divided by 4 pi epsilon 0. So these are nothing but ij or ij square. So fx is x by r. Did I miss negative sign? Yes. So here we had a negative sign, and here from del u we got another negative sign there. So that negative becomes positive. So this is my x component of force acting between two particles which are having charge. Likewise, I guess you can calculate the x or y component of force between two Lennard-Jones particles, and I am giving you again some time to calculate the force between two Lennard-Jones particles.